So in this part, we're going to talk about special cases. So there's many types of special cases. When you see a particular problem involved with logs and their questions and the format of the question, you should be able to recognize which type of the special case and then easily identify the answer without doing any work. So again, we're just going to go over some special cases. Make sure you be familiar with them, so that when you come across a problem that you should be able to easily recognize it and identify the answer or what type of work you need to do when solving it. So our first special case is when you have log base b of b. When you see a particular problem like that, then you can automatically set it equal to 1, and that's it. That's all it is. So you can just say x equal to 1. So for an example, if you have log base of 5 and then 5 in parentheses, then the only answer you have left is just 1. So you can just say x equal to 1. Let me do another one. If you have another log of base 2 of 2, then the answer is 1. X equals 1. Now the reason is, if you were to rewrite this in exponential form, I'm doing this one right here, the second one. If you were to rewrite it, this is my base, 2. This is my exponent. 2 to the 1 power is just 2. That's how many 2's there are, which matches with that. So, when you have a log of base b of b, like log base 5 of 5, or log base 2 of 2, then it will equal to 1. Keep in mind on what type of numbers you have here. I want to talk about other special cases, especially with numbers inside the parentheses, or when you're doing a log of the number. In this next special case, we have log base b of 1. When you have a log in this format, with any base that you do a log of 1, then it will automatically equal to 0. X equal to 0. So let's do an example. Say you have log base of 4 of 1, then it will equal to 0. X equal to 0. Say, let's do another one. Log base of 9 of 1, it will also equal to 0. So x equals 0. Now, if you were to rewrite this log in exponential form, my base 9 to the power of 0, anything that's powered by 0 will equal to 1. And this is from chapter 5. Anything to the 0 power will equal to 1. So this is a special case when you have a log of any base with the 1 inside, or you're doing the log of 1, then it will always equal to 0. Log base of 4 of 1 equal to 0. Log base of 9 of 1 equal to 0. Again, this is from chapter 5, where any base to the 0 power will equal to 1. So therefore, when you have a log in this format, then it will equal to 0. For this special case, let's pay attention to these two examples I have here. On my left, I have log base 3 of 81, and on my right, I have log base 3 of negative 81. Now here, if you were to rewrite this in exponential form, you can easily find what the exponent is. Like how I did before, set equal to x, and x should equal to 4. Because 3 to the 4th power will equal to 81. Now over here, if you set it equal to x, and you were to rewrite it in exponential form, 3 to the x power equal to negative 81, well, you will see that the numbers I gave out to you in the previous chapter, in the previous sections, then you notice how I didn't give you with negative numbers. So, regardless of your base, if it's positive or negative, the numbers that I gave you, I didn't give you out any negative numbers. Now, I did mention about how anything to the odd power, let me take a step back. For anything in exponential form, if it has an odd power, then your answer can be negative if it's an odd power. But here, 3 to the 4th, my power is an even number, so it's kind of hard to make this a negative number unless I'm multiplying by a -1 here. Then, yes, x can equal to 4. That's if I'm multiplying by -1. But in this case, I'm actually not. From this problem here, I am not multiplying by -1. So, it's going to be hard for you to find an exponent when over here, 3 to the 4th is 81. But we're trying to make this one equal to -81. It's going to be harder for you to find an exponent when there is none that exists at all. So, when you see a log of a negative number, then you can just simply say undefined. So that's your answer. Because the program for log function, when you use it on a calculator, if you input a negative number, it would say either undefined or no real solution. It's because the log function is not programmed to work with negative numbers. Now, I did mention if we're working in exponential form and you're working with odd numbers for exponents, then we can work with negative answers, negative numbers, but only in exponential form, not in log form. So, if you're working in log form and you have a negative number here, or you're doing a log of a negative number, then your answer will be undefined. So what happened if you have a log with a negative base? So let me give you one. So log base -2 of 4 equal to x. Now, if you were to rewrite this in exponential form, -2 in parentheses with the x set equal to 4, then if you could do it in exponential form, then x will equal to 2, which is fine, but only in exponential form. But when you're doing in log form with a negative base, then if you were to type this in a calculator or trying to work with it with base of change formula, which we will cover in the later section, then this will be undefined. So, if you have a negative base or a negative number, then it will be undefined. Again, log is not programmed to work with negative numbers. But if you were rewriting in exponential form, in this case, then yeah, you can work it out as long as there's parentheses on the -2 base. Because if you don't, and if you were trying to use this as a calculator for a system, then you might get a different answer. So, if you have a negative base, most likely it will be undefined. In this special case, we have log base b of 0. So if you set this equal to x, and then rewrite it in exponential form, b to the x power equal to 0. Now, let's go back to the numbers I gave you in the previous section, the numbers with all the powers. When you look closely to those numbers, you notice how none of the numbers I gave you equal to 0. And the reason is because if I do an example, say log base of 6 of 0, and I set it equal to x, if I rewrite it in exponential form, 6 to the x power equal to 0, it will be impossible for you to find an exponent, regardless if it's a whole number, a fraction, a decimal, or a negative exponent, where it will equal to 0. There's literally nothing that will make this equal to 0. In the previous example, we already covered that anything to the power of 0, so say like 3 to the power of 0 is 1, or negative 4 to the power of 0 is 1, or 5 to the power of 0 also 1, negative 35 to the power of 0 equals to 1. So anything to the power of 0 is 1, but a base to the power of an exponent will not equal to 0. So it's going to be impossible for you to find an exponent where a base powered by an exponent that is equal to 0. So when you see this form, or another example, log base of 7 to the 0 power, not 0, log base 7 of 0, when you see something like this, then the only thing you can say is undefined. So, you don't need to do any work whatsoever. Is when you see a problem, a log problem, with this form, like log base 6 of 0 or log base 7 of 0, then you could just write undefined, because it will be impossible. There's no way for you to find an exponent where it will equal to 0. So 6 to an exponent or 7 to an exponent of x, you won't be able to find an exponent where it will equal to 0.